two coordinate systems n1 and n2 and a1 and a2. So now we want to write the vector p as px n1 cap plus py n2 cap. So you want to go from the origin here to the point P over here, then you have to travel a distance of px along the n1, right, till here, and then you travel vertically upwards a distance of py along n2, which is this, right? Okay. Now the vector p in a1 and a2 can be written as small p x a1 plus small py a2. So you travel small px along a1 along this line, and then this is supposed to be perpendicular, and small py along a2. So now how do you do the transformation? So if you look here, you can, from the equation, so the angle here is theta, angle here is also theta, angle here is theta, angle there is also theta. So now your px, capital Px, which is this length, is equal to, now this is this whole distance is O, let's call it OA. So that length, which is small px cos theta, small px cos theta will be this whole length minus that length, right, which is same as this length, which is minus py sine theta. Similarly, py, capital Py, can be written as small px sine theta, small px sine theta, which is this height, small px sine theta, plus small py cos theta. Py is, small py is this length, small py cos theta is this. Okay. So when we write this in matrix form, capital Px equals to capital Px, capital Py is equals to cos theta minus sine theta, cos theta times small px, small py. Now this is the vector p expressed in n1, n2, n3 coordinate system. This is a vector p expressed in a1, a2, a3 coordinate system. So this is a transformation matrix. We'll call it n underscore a. So any vector which is expressed in a when pre-multiplied by this transformation matrix will be then expressed in n, in the coordinate system n. So this is the transformation matrix. So transformation matrices always satisfy n underscore a, the transformation matrix, inverse of a transformation matrix is always equal to its transpose.